Good day, everyone, and welcome to the shop. It's been an exciting week. Last weekend I actually wrapped up 2 months of building my own sandblasting cabinet, and the thing actually works. So why would I actually do this? I didn't need anything special except a large cabinet, so I wanted to be able to do something that was 72 inches long. I've got rock rails for the Jeep, for example, that need redone. And I also needed something that could fit a 30-inch deep object. I'm trying to make my own disc golf baskets, and some of those they're not quite that big, but they're close. And so I just wanted that depth. When I was looking at options to purchase something, you don't have a lot in that size. So an acquaintance of mine gave me an idea, which was, well, why do you need a cabinet for that? Why don't you just buy like a small benchtop cabinet for, the smaller things that you do, and then buy a portable unit and do your large sandblasting outside? That certainly would have been cheaper. I decided against that approach because two primary reasons. One, you're not going to want to do that in the winter. I mean, you're not going to want to sandblast outside in the winter. So that was going to limit the usage there. And I'm also just kind of trying to be a good neighbor. I mean, I really don't want to be sandblasting outside. I feel like the neighbors are not going to appreciate that. So I scrapped that idea, started looking at cabinets that were large to buy, and you don't have a lot of options for something in that size range. So I looked at the Redline RE49. Looks like a nice cabinet, but the dimensions on that I think are 79 long, 26 5/8 deep, and 26 tall. So, not deep enough for my needs. And that was like $3,250, I think. And then you were gonna have tax on top of that, and probably shipping as well. So it was pretty pricey. The next option is I found a cool company named Sandblast. Actually, made in the USA cabinets. They're out of Ohio, and they seem really nice. And their prices are competitive with cheap imports. So that was very compelling. And they have two models that were close to what I wanted. One is their Model 985. That has dimensions 72 long, 28 deep, 28 tall. So not deep enough for what I wanted. It might have worked for my current needs, but if my current needs are at the very edge of what the cabinet offers, odds are I'm going to outgrow it. And if you're talking about spending $3,000, which is about what that would be with sales tax and shipping and whatnot, I wasn't willing to risk that. So then their next larger model, they do have a commercial line, and they have model 1636, which offers 72 inches wide, 34 deep, and 36 tall. So it's huge. Obviously would have met my needs, but it's $6,000 plus sales tax, plus $330 shipping, plus a $50 liftgate fee. You're up to about $6,700. That's a lot of money. And I don't think that I could do enough sandblasting in my life to justify that for a home shop. Scrap that, which leaves you with one option, which is to build your own. So that's why I built my own. And here's what I came up with. Well, so here's the cabinet. Obviously, cabinet on the left, and then the tray is extended on the right with a workpiece on it. And I'll demonstrate, how that works. Worked better in theory than in practice. Let me show you what I'm talking about. So this is going to work just fine right now because I've kind of got the cabinet cleaned up a little bit. There is one issue, but you'll see that in a second. So move the kickstand and then just slide it in. there's the problem. So move this over here. When you get to this point, so I've got the gun and the first two gloves kind of suspended, but the last two gloves are now in the way. So you gotta come over here, lift your gloves up, make sure they're on the tray. Then you can push the rest of them in. And there you go. So a friend of mine had a really good idea for the gloves, which is to glue a magnet on the inside, and then when you're not using them, you just slap it to the side of the cabinet. Should keep them from getting in the way. Just haven't done that yet. So on the inside, let me show you where the problem is with this sliding tray design, is that, it runs on bearings. Here's one, got another one here, and it's just running on a 5/16 rod, so works just fine when it's clean. After you've been blasting, whatever your media is kind of builds up along the edges, and then it doesn't roll anymore. And I didn't anticipate that when I was drawing all the plans and everything. I was talking to an acquaintance of mine. He did anticipate it because he actually brought that up to me, and I forged ahead anyway, as I typically do, ignoring the advice of those older and more experienced. And he was right. It does seem to pull out fine. There's some resistance, but you do have to clean all of that up before you run this back in, which, it's not a huge deal, but a little bit of an annoyance. So, tour of the rest of the cabinet. So we'll just start at the top. Obviously, I've got air coming in. This is the second moisture trap in the system, and you definitely need that here in the humid environment. Electrical connector for the lighting. This is my air inlet, and that's just a piece of felt as a filter, obviously to keep dust from coming out. Don't care about what's going in. Air outlet, and follow that line, comes down to my little Oneida dust deputy. I don't think this thing's really doing anything. It's meant for larger debris, but I wanted it in the system anyway. And then a very, very janky adapter to just a standard shop vac. Obviously, two LED lights there. They're 7-inch lights. It's not quite enough. I think I'm gonna put two more in and mount them here and here, which will essentially be illuminating the work, right as you are looking at it. So I think once I've got 4, that's gonna be plenty. So all right, over here, I've got air in, and we're gonna trace this backward. So that comes down to a foot pedal, which then goes back up to the air source. Obviously electrical switch for the lighting. Here's your siphon tube. So that goes down into a 4-way union. And I've got a valve here. You gotta crack this a little bit just to allow air to move through and get that siphon action going. And then so here's one of the mistakes that I made. My original design, I had my siphon tube here in the side of the hopper, and that just ended up not working as well as I wanted. So moved it down to the bottom of the doors on the hoppers. So you can see that on each side. And we'll see if that works better. As you can see, each door's got just a simple latching mechanism. And I guess the last thing to show you will be the door and how that works. So I'd originally wanted a hinged door, that you would just pull open. And as you can see, I've got some clearance issues. Definitely my mistake in not, I measured appropriately, but I didn't really model how I would be using it, so I didn't anticipate this was going to be in the way. So couldn't do a hinge. So what I ended up doing is just magnets. So I've got some guides here for where you want the bottom of the door to be. And then you just kind of stick it in there and Of course, electrical connectors. So this is not as easy as you would want. But once you've got it where it should be, it does seal. I mean, it seals just fine. So I've got, I don't know, maybe, I think I've got 8 neodymium magnets. I think 1/8 inch thick by maybe like 2.5 inches long. And so I use the milling machine just to mill slots in the 1/4 inch flat that goes around the perimeter here. And so that way they're flush, and and then I've just got a little silicone door seal all around the outside. Seems to be working great. I wish it were a little easier to put the door on, but it's fine. Only other thing, I guess, is a look inside. So obviously there's the gun that is from Scat Blast and seems to work great. You can see I fashioned a little hook. It's just a magnet with a piece of, I think, 1/8 inch round JB welded to it. Seems to be holding up. And yeah, there's not a lot to see in there. Okay, so overall, pretty happy with what I did. I covered a couple of mistakes that I made in the tour. Here are a few more. So if I were redoing this, I would definitely change the location of the cabinet. As you saw, it's in a corner, which I wanted to do that because it would be out of the way. I was never gonna have to worry about having to work around it, essentially. That was a big mistake. I have already noticed that I should have went for a double door design where you could access it from either end. The sliding tray, as I said, works sorta. The bigger issue though is when you're like loading media into the far hopper, that's kind of a pain. And if you have to actually do anything like back there, you got to crawl into the cabinet. It's not as good of a design as just having both doors or both sides open and accessible. So I would have put it on a wall where I had access on each end. The shop vac as dust collector is way too loud. So looking for a quieter vacuum to hook up to that dust collection port. Last thing that I didn't mention before is I would have moved the air and siphon tube inlets into the front of the cabinet. I would move those underneath. I mean, in my current configuration, they're not really in the way, but I don't like the way that it looks. And if I had put it in a different location and you had access on either side, I think that design would have been a mistake, and they should be up underneath, completely out of the way, basically. So the big question is, what did this thing cost? Doing it myself, there was obviously a lot of labor involved, so there's a big trade-off between buying and building. So the cost of the metal by itself, I bought almost everything through Metals Depot. So $1,300 in metal, roughly. Miscellaneous supplies, so that covers the polycarbonate sheeting, fasteners, fittings, air hose, the gloves, the gun, all that other stuff. It came up to about $1,300. So $1,300 in metal, $1,300 in miscellaneous supplies. And then on top of that, you've got kind of tools and consumables. I bought a second grinder. I bought an Evolution, metal cutting circular saw. And then, just things like, JB weld and all those little things. So they add up. All of that's about $700. So all in, $1,300 for metal, $1,300 for supplies, $700 for tools and consumables. You're at about $3,300, and that also includes sales tax and everything. So $3,300 all in on this project, which is about the price of the smaller Scat Blast cabinet that I was looking at. But I've got a much larger cabinet that pretty happy with overall, despite making some mistakes. So economically, I feel like it worked out. Lessons learned, I gave you some mistakes that I made. As far as other lessons learned, I do not have a welding table or a layout table of any kind, and I really wish I would have invested in one, just something large and used off of Craigslist. Not having that caused a lot of delays. Just everything that you did took a little longer. So that would have been something to invest in ahead of time. Mentioning that Evolution metal cutting circular saw, I would not buy that again. Not to say that it isn't a nice tool. It's a very nice tool. It cuts through metal very easily. I just ended up not using it much. I ended up preferring to use a cordless jigsaw with a bimetal blade in it. That cut through the sheet metal, 14 gauge sheet metal, just fine. I have found, I think, 3 cordless grinders is an ideal number. I don't have 3, I only have 2. I bought one partway through the project because you're constantly changing out tool heads on it. So, you need one that's got a wire wheel on it, or a wire cup. You need one that's got a grinding cup, and having one that's got a cutoff wheel on it. Having those ready to go at any moment will save you a ton of time. If you're doing this by yourself, which I did, I would really recommend having a shop crane. Just moving large, heavy objects around the shop by yourself without hurting yourself, it's a skill. And having the right tools really helps with that. And the shop crane was invaluable. And then whether or not you're doing this on your own, you need a lot of clamps, and you need to use them creatively. There are certain things you're going to do where you can't just clamp 2 things directly together, like this. And I learned you can't cut hot rolled sheet with a bimetal hole saw. I ruined 2, a cheap one and a nice one, and eventually just ended up having to use the jigsaw, which is not ideal for smaller holes, or stepper bit for smaller holes. Hole saws just wouldn't touch it. I'm sure a carbide tipped one would. I didn't have those. So those are some of the things I learned along the way. Would I do this again? That's the ultimate question for any project when you get to the end. Would you do it again? Absolutely. Economically, it made sense, paid off. And the most important reason that I would do this again is that I did learn a lot. I don't have a ton of experience working with metal. Before this, I was a very, very poor welder. And I feel like through this process, I've gained a ton of knowledge. I've gained some skills. I can weld things together now that don't look completely terrible, and that I'm quite sure are structurally sound. So I would absolutely do it again just for the learning experience. And that brings us to the ultimate question: should you build your own? I think you should. If you have the need, the interest, the time, time's a big one, and the tools, or you're willing to pick them up, absolutely. It was a frustrating experience at times. I think friends got tired of asking me, well, what are you doing this weekend? I'm continuing to work on the cabinet. But after it's all said and done, it was very much worth it. I have a great capability now, and I have new skills that I didn't have before. So overall, very much worth it. So if you have any questions that weren't covered here, something, how did you do this? How did you do that? How's it working out long term? Happy to answer all of those. Always happy to help. With that, until next time, thanks for watching, and farewell.